In this video, you will learn the impact of the power factor, the total harmonic distortion, on the global power efficiency of LED driver. Okay, below 25 watts, it's not an obligation to have a power factor controller. So this is a 3 watt LED, for example. This is a 6 watt. So it turns out the specification will say 6 watts and says 100 lumens per watt. Okay, but they measure the 6 watt and they never tell you how many watts it's taking from the mains. And when you don't have a power factor controller, globally you lose about 50% of energy. So in fact, the reality is you don't have 100 lumens per watt, for example, but 50 lumens per watt. Okay. What is interesting to make the point with my test lab equipment, I will demonstrate that key thing using an 18 watt LED tube with its ballast. It's interesting because this company has decided to put a power factor controller. Okay, and I will also do the same with a 100 watt LED driver and with the driver. Of course, here it's an obligation to have a power factor controller. Okay, let's start with the 18 watt tube. Okay, this is the DC power feeding the LED tube, so it's the output of the ballast feeding the tube. The current, the voltage. So we got about 33 volts here and about 548 milliamps. So roughly it's about 18 watts as claimed by the data sheet. Okay, now let's go out the input of the ballast from the mains. Okay, well, the good news, we can see there is a power factor controller. Okay, but a lot of distortion. It's not such a good one, even though one could think the power factor is good. You see, making that special measurement, we estimate 98% power factor. Okay, now with this tool, this is the input voltage, so you have to multiply by 2. This is the input current, so it's using about 22 watts. And now let's check the total harmonic distortion. See, it's beyond 80%, confirming I would say the issue. So we are in a situation, or in theory, okay, good power factor, very bad total harmonic distortion. So at the end you have about 85% efficiency. They claim 100 lumens per watt here. In fact, it's, let's say, 85 lumens per watt, because it all depends where you make the power metering measurements. Okay, now let's look at the 100 watt LED. Okay. The DC output of the LED driver, now we've got about 37 volts and here about 2.89 amperes. So it's a bit more than 100 watts. In fact, it's about 107 watts. Please make a note, it should be around 100 watts. Okay. Now, if we look at the mains, now we see a much better power factor controller. Okay, you can see that the distortion is much less. That's the value. Let's shift to the input power. So now it's using, you have to multiply by 2 here the voltage, and here about 476 milliamps. So it's using about 118 watts. So the global efficiency is much better. We got a bit beyond 90%. Okay, even though that if we try to see the power factor here, it would be not so good as the previous one. It's about 95%. So you can see these non-linear things. Okay, anyway, we're in a situation now where Okay, it claims 100 lumens per watt because they understand the way they measure it. But the truth is, now it's about 90 lumens per watt because you have to make the global efficiency. The conclusion of this technical video, okay, it is important to have a good power factor controller and a low total distortion harmonic. But as you have seen, this product has 95% power factor, but it has a global efficiency better than this product, which has 98% power factor, but its efficiency is 85%. So they claim 100 lumens per watt. In fact, it is, let's say, 85 lumens per watt, whereas this product has a global efficiency of 90%, so 90 lumens per watt, even though they claim 100 watts, because, as you understand, there are many ways to measure and present the efficiency.